All right, class. Welcome to this review of 2.1 to 2.3. So, right now we're going to cover the following questions from the review packet. So, looking at the first one, so we want to be able to describe the transformations of g of x equals negative x plus 1 squared minus 3. So, remember that the vertex form is f of x equals a times x minus h squared plus k. So in this case, a tells us what direction the parabola opens. So if a is positive, the parabola opens up like this. If a is negative, the parabola opens down like this. And then h tells us if it's going left or right. And k tells us whether it's going up or down. All right, so it's in this case, if there's a minus on the inside, it's going right. If there's a plus on the inside, it's going left. If there's a positive on the outside, it's going up. If there's a negative on the outside, it's going down. So in this case, if we're looking at g of x, well, so let's rewrite this. G of x equals negative 1 x plus 1 squared minus 3. So in this case, so since it's plus 1, that means it's going to the left 1. So it's like opposite in the inside, right? So plus on the inside means left, and minus on the outside means going down. And the minus on the outside here, and the minus in front of it, means that the parabola is going down. Okay, so for number 1, the parabola is, so we call this concave down. Concave down means that the parabola is, going down. All right, so that's all we know about this. Now remember also that if, like for example, if instead of this being a 1, it was like a 2, x plus 1 squared, for example, that if it was a 2, that means that it's going to be vertically stretched as well. If that were like, for example, a half times x plus 1 squared minus 3, then that means that it will be vertically compressed. Okay, so these are all things that you should be, on the lookout for when it comes to transformations. All right, so for number 2, find the key features of the function negative 4 times x plus 4 squared minus 2. All right, so let's write that over here. I believe it was x minus 4. Let's double check. X plus 1. Negative 4, x plus 4 squared. All right. So in that case, if we want to determine the key features, so what do we mean by key features? We mean like axis of symmetry, domain, that kind of stuff. So let's do domain since that's easy. The domain of a quadratic function is always negative infinity to infinity. Why is that? Because if you look at the graph, right, the graph, looks like a U or upside down U. In this case, since it's negative, it's an upside down U shape. So it's looking something like this, right? So that means if it's looking like that, it's going forever in the negative x direction, and it's going forever in the positive x direction, since this is going forever. So that's what we got all real numbers in the x direction. Okay, so that's it for the domain. Whenever you see a quadratic, automatically negative infinity to positive infinity. Next thing we want to figure out is the axis of symmetry and the vertex. So let's do the vertex real quick because that's probably the easiest one to do, or one of them easiest. So in this case, remember that the form is ax minus h squared plus k. So you see the plus 4 here, and here it's minus. So that means that if it's a plus here, it becomes negative. So if you see a plus here, it'll just be negative 4. So it's the opposite for the x value. For the y value is exactly what you see. So in this case, it's going to be negative 2. Okay, so if you see a positive here for the x value, it's going to be negative. If you see a negative for the x value, it's just going to stay the same, positive, right? So just flip the sign for the x. All right, so that's how you find the vertex. All right, so that means that in this case, we got the vertex, and the axis of symmetry is actually quite easy. Once you find that vertex, then the x-coordinate of the vertex is your axis of symmetry. So that's it. Whatever the h-coordinate is your axis of symmetry. So x is equal to -4. Very simple. So now to find the range as well as the minimum maximum. So in this case, since we know that the graph is going down like this, right? It's going down. That means we have a maximum. Okay, and we know that the vertex is -4, -2. Okay, so that means, so let's be more specific with the graph. Okay, so that means when we do the graph, right, it's going to the left 4 and down 2. So this is our vertex, and it's going upside down. So it looks something like this, right, where this is our vertex. Now, this means that it has a maximum, and the maximum is at the y value. So in this case, we have a maximum at, in this case, the maximum is at the -2 value. So you're always going to use the y value for the maximum. So use the y value when you're doing the maximum or the minimum, okay? So the maximum is equal to -2. All right, so now that we know it's a maximum, now we can find the range. Okay, so the range of this guy is the y values, right? So if you look at the y values, the biggest y value that we have is -2. Right, that's the biggest y value that we have. So that means that y is going to be less than -2. So you notice that the graph only goes below -2, right? That indicates that y is smaller than or equal to -2. So you can write it like this. Or, so you could write it like y is less than or equal to -2. Or you could write it like, you could say that we start at -infinity and we go all the way up to -2. So that's another way of writing it. Or -infinity to -2, including the -2, because that -2 is part of the graph. Remember, this means that you include it, and parentheses means you don't include it. So these are two ways of writing the same thing for the range. Either one is fine. Okay, so let's give you another example just to make sure that you're okay. So if we had something that was like, say, x minus 4 squared plus 2, and it's positive here, right? So it's a +1, then we know it's going up, and we know it's going to the right, and it's going up. So it's going 1, 2, 3, 4, 1, 2, then it's going up like this. In this case, the range, if you were to do the range, the minimum y value is 2, and then it only goes up from there, right? So that means in that case, you would say it starts at 2 and goes up to infinity. Or you could write y is greater than or equal to 2 in that case. So there's another little mini example in case you needed to see, how it looks like if it's positive, if the graph is going positive. Oops, let me go back real quick. There you go. All right, so now let's look at the next problem. Number 3, find the vertex, axis of symmetry, y-intercept, and graph of -x squared plus 2x minus 8. Okay, so let's Let's rewrite that problem. So this is number 3. It's negative x squared, my bad. Plus 2x minus 8. So first things first, they want us to find the vertex. So if we want to, so right now we know this is a standard form. So if we wanted to find the vertex, then that's going to be our coordinates hk, right? So we need to find the h. So to find h, we're going to be using this formula. X or h is equal to negative b over 2a. So remember that this is a, this is b, and this is c. So in that case, we can plug it in. We get negative 2 over 2 times a. Negative 2 over negative 2, which is positive 1. So now we got our h coordinates. So remember the vertex is given by hk, right? So now we got h is 1. So now we need to get our k coordinate. How do we get our k coordinate? To get our k coordinate, you need to plug this into the original function. So you need to plug this in. So if we were to do that, right, we get f of 1. Now we're going to plug in 1 for x. So negative x is 1 squared plus 2 times 1 minus 8. So 1 squared is 1. So negative 1 plus 2 minus 8. If you did the math here, you're going to get 1 minus 8 is negative 7. So that's my k value. Okay? So this is my k value. So this is my vertex. So you plug that back in. So vertex is 1, negative 7. All right, so that's how you find the vertex. If you wanted to do, we wanted to find the axis of symmetry, y-intercept. Okay, so now we want to find the axis of symmetry. Axis of symmetry is easy, right? Once you find the vertex, take the x coordinate of the vertex. So x is equal to 1. That's it. That's your axis of symmetry. X equals 1. Now to do the y-intercept, you're going to set x equal to 0. So you're going to set x equal to 0 in the original, right? So in this case we got negative 0 squared plus 2 times 0 minus 8. So negative 0 is squared, it's just 0. Okay, so this is 0. 2 times 0 is just 0. So really we're just left with negative 8. So my y-intercept is negative 8. So this is my y-intercept right here. Okay, so now we want to make a graph from this, from these three things. Okay, so from this, this, and this. So how do we make a graph from that? All right, so we got the vertex is 1, and then we're going down to negative 7. So the vertex all the way down here. And we know that the parabola is negative, right? So right here, we know that this is negative. So that means it's going down like this, right? So we know the parabola is going down. And also, we know that the axis of symmetry is x equals 1. So what we're going to do is we're going to draw the axis of symmetry through x equals 1. Okay, so that's this guy right here. And then we know that y equals negative 8. So I'm going to plot this one in red. So negative 8 is down here. So that's over here. Okay. So now we have half of the parabola. So we can go ahead and draw this half. Like that. Now we know that this parabola is symmetrical, right? So if we draw that point, then we should be able to draw an equivalent point on this side. How far away? Well, we know that this is 1, so we know that it's 1 away from this guy. So it has to be 1 away from the other side. So it has to be at 2. All the way from 2 and then -8. So let me do that point in blue. See how they mirror each other? And now we can draw our parabola. Okay? And that's our guy. So that's a more specific graph. Okay, so we're going to do the same thing for that, but we're going to do it for number 4. So we have 4x squared minus 16x plus 14. Okay, so let's do it over here. This is a plus 14 right here. All right, so again, find the vertex, right? Vertex is HK. And to find H, we use, so this is A, B, C. So negative B over 2A, negative 16 over 2 times A. So 2 negatives make a positive, so it's 16 over 8, which is 8, or 2. So H is 2. Then plug that into the original. So we have f of 2 equals 4. X is now 2. 2 squared minus 16 times 2 plus 14. 2 squared is 4. 4 times 4 is 16. So let me just write this out. That's going to be negative 32 plus 14. Okay, so we got 16. So this right here is 16 minus 32 is negative 16. Negative 16 plus 4 is negative 2. So this right here is my k value. So now we got our vertex. All right, done. Vertex is done. Now we need the axis of symmetry. That's also easy. Axis of symmetry. X equals 2, using that x coordinate. Done. Axis of symmetry is done. Next we want to find the y-intercept. So to find the y-intercept, you're going to set x equal to 0 in the original function here. So we got 4 times x squared, 0 squared, minus 16x, x is 0, plus 14. So this is 0, so this will be 0, this will be 0, so we just left with 14. So y equals 14. Done. Now we can graph this guy. So let's graph him real quick. So we got the vertex is 2, negative 2. So vertex is over here. We know that x is equal to 2 for our axis of symmetry, so we graph it going through here. And then we know that the y is equal to 14, so we're going to go all the way to 14. 13, 14. Okay, so 14 is all the way over here. This is 14. And then we can draw the graph. So basically it cuts through 14. It's not a very good graph, so let's do the best we can. Let's see if we can do a little bit better. Something like that. It's very skinny. It's a very skinny looking graph. And then we're going to mirror that graph on this side. So right now it's 2 away on that side, right? So it has to be 2 away on this side. So that means it's at 4, 3, 4. So now we can draw that point and then draw the other half of the curve. Okay, so there's our parabola. So that's how you graph if it's in standard form. Okay, there are multiple ways to graph, but this is just one technique that we use. All right, so that's number 4. Number 5, if a projectile is fired straight upward from the ground with an initial speed of 125 feet per second, then its height h in feet after t seconds is given by h of t equals negative 16t squared plus 128t. Find the maximum height of the projectile. Okay, so they give us a function that's a parabola, that's a quadratic, and they want the maximum height. So h of t equals negative 16t squared plus 128t. So let me write that out. Negative 16t squared plus 128t. Okay, so first off, notice that the a here is negative, right? And this is b. And in this case, c is equal to 0. All right, so really there's no c here. Okay, so in that case, we know that since a is negative, that this parabola has to be going like this, right? Concave down. So we know it's concave down. So that means it does have a maximum, right? So it has a maximum somewhere. So we need to find that maximum height. How do we find it? Well, the maximum height is the vertex, right? So we need to find the vertex. We need to find the y-coordinate of the vertex. So in order to do that, we need to use the formula, right? So in this case, h, remember the formula, h equals negative b over 2a? We're going to be using that here. So b in this case is 128. A is negative 16. So you get negative 128 over negative 32. So h is equal to, in this case, 32 goes into 128 4 times. Okay. So this means this is h equals 4. So this is the x coordinate, right? So this is the x coordinate of the vertex, or the h coordinate. Now they want the maximum. The maximum is the y coordinate. So we want the y coordinate of the vertex. So we need k. Okay. So in order to get k, we're going to plug this 4 into the original. Okay. So we get negative 16 times 4 squared plus 128 times 4. In that case, so we got negative 16 times 4 squared is 16. All right, so now we got to do 128 times 4. So we're just going to do this by hand. All right, so we get 512 for that. And then negative 16 times 16 is negative 256. And then if you add those together, you should get another 256. All right, so 256. 256 what, you may ask? 256 feet, okay? So that is my k coordinate. So that's k. So that's over here. So 256 feet. And this right here is time. So this is in seconds, right? So here this is time. And h is in feet. So that means the maximum height is 256 feet. And that's the height that the projectile travels in. So if they're asking for like a minimum height or a maximum height or something like that, you're going to be finding the y-coordinate of the vertex. All right, so basically that's what they want. All right. So now for number 6, we want to be able to convert that to vertex form. So x squared minus 2x plus 3. Okay, so remember that vertex form. We want to convert this to a x minus h squared plus k, right? F of x equals that, right? So let me write the f of x here. So we want to convert that to f of x equals that. So we automatically know that a is 1, right? So we know a is 1. So that takes care of this guy. We automatically know that that guy is 1. So we need to find h and k. How do we find that? Well, we did it earlier. You're going to be using the formula for the vertex, right? So we got A, B, C. So we got negative, B is negative 2. So we got negative, negative 2 over 2 times A, which is 1. So two negatives make a positive. So we have positive 2 over positive 2, which is 1. So now we got our h. So h is equal to 1. Now to find our k, we're going to plug the 1 into the original for x. So we got 1, so x squared, so 1 squared minus 2 times x, which is 1, plus 3. So we got 1 minus 2 plus 3. So this will be negative 1 plus 3 is 2. And this is my k value. Alright, so now we can go ahead and plug that into the vertex form. So we got f of x equals a is 1, an invisible 1. But I'm just going to write it here just for emphasis. X minus h is 1, so we got 1 squared, and then k is 2, so we got plus 2. That is our vertex form. Alright, so that's what they were asking for. Now going on to number 7. Convert negative 2 times x plus 1 squared minus 3 to standard form. Okay, so we got number 7. Negative 2 x plus 1 squared and then minus 7. Okay, so I want to make sure, want to confirm that that's correct. Okay, so that's correct. Alright, so we want to convert this to ax squared plus bx plus c, right? Basically. How do we do that? We're going to need to FOIL this guy. So remember, that squared there means that you have two of these guys. So we're going to rewrite this as f of x equals negative 2. Rewrite this as x plus 1 times x plus 1 minus 7. Alright, so we got to FOIL this guy. So this is a FOIL. Okay? So we got to do x times x. We're just gonna ignore the negative 2. We're just gonna bring it down. So x times x is x squared. Now we got to do x times 1 is positive 1x. Now we got to do positive 1 times x is positive 1x. And lastly, we need to do 1 times 1 is positive 1. Alright, now minus 7. So now we're done with the foiling. Now we're going to distribute. Actually, before we distribute, let's combine the like terms here. So we got negative 2 x squared. So this is a 1x, this is a 1x. So we got a total of 2 x's here. Now we can distribute just to make it a little simpler. So we got negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 2x, or negative 4x. And then negative 2 times positive 1 is negative 2. Bring down the minus 7, combine your like terms here, and you're done. So we got f of x equals negative 2x squared minus 4x minus 9. Negative 2 minus 7 is negative 9. And that's my standard form. So that's how you convert from vertex to standard form. Alright, so now let's look at number 8. We want to be able to factor x squared minus 3x minus 28. X squared minus 3x minus 28. Let's do that over here. Alright, so if we want to factor this guy, notice that the a is 1. If a is 1, we don't have to do AC method. So let's go straight to doing our x table. So we need the numbers that multiply to negative 28 but add up to negative 3. Alright, in that case, the only numbers that work here So this is probably the hardest part, is being able to find these numbers. So I know that if I did 7 times 4, that will give me 28. But we need it to be negative 28. So one of these numbers has to be negative. So if I did negative 4, well, 7 minus 4 is positive 3, and we want negative 3. So it has to be negative 7. So negative 7 plus 4 is going to give me negative 3. So this right here is correct. So we want to use these two numbers. Once you find those two numbers, write your double parentheses. All right, so we got x in each parentheses. And then you're going to use your two numbers that we found. So we got minus 7. And then the next number is a positive 4. So we got positive 4. Okay, in that case, that's our final answer. X minus 7, x plus 4. All right, now let's look at number 9. So number 9, they want us to factor 3x squared minus 11x minus 20. So 3x squared minus 11x minus 20. Okay, so we know that our a here is 3, and it's no longer equal to 1. If a is not 1, then you need to see if you can pull it out, or AC method. In this case, we cannot pull out a 3 because 3 does not go into 11 and 3 does not go into 20. So that means that we're going to use the AC method. So we need AC method here. Okay, so we need to do AC. So AC is equal to, A is 3, C is negative 20. So we got 3 times negative 20 equals negative 60. Then you do your X table. So negative 60 goes here. So so we need two numbers that multiply to negative 60 but add up to negative 11. All right, so two numbers that work out here. I know that 5 times 12 is 60, but 5 and 12 does not add up to 11 anyhow. So it's not 5 and 12. If I did 4 and 15, 4 times 15 is 60. So like I said, this takes practice. The better you are at factoring our factors, then the better you are in this step. So I know 4 times 15 is 60, and I know if I made negative 15, then I know that negative 15 plus 4 is negative 11. So I know I can use these two numbers. Again, this part is probably the hardest part. Of course, you have to remember the other steps as well. Okay, so now that we got those two numbers, do not go straight to the parentheses form, okay? You need to do one more thing before you do that. So you're going to split this number, this middle number, into the 4x that you found here, the 4. So split it into 4x, and then also split it into negative 15x. Those two numbers that you just found in the puzzle, okay? Those are the two numbers that you found in the puzzle right here, right? So split it into those two, and then rewrite the rest of them. So rewrite the minus 20, and then rewrite the 3x squared. And this is a positive 4, so I'm going to write a plus there, okay, because this is a positive 4 over here. All right, so now we rewrote it. So now we're going to, group these two guys. So I'm going to put a plus out here and then put a parentheses around these guys. Okay, so what can I factor out of the first group? Well, I can only factor out an x because they only have an x in common. So I'm going to pull out an x. So x is on the outside. So if I pull out an x, that means I only got one x left over. So x to the 1 power. If I pull out an x from the 4x, then I'm just left with 4. So I'll have plus 4. Now what can I pull out of this guy, the second group? Well, I can pull out a negative for sure. And I can also pull out a 5 because 5 goes into 15 and 5 goes into 20. So I'm going to pull out a 5. Now if I do that, parentheses, 5 goes into 15 3 times with an x left over. And then negative 5 goes into negative 20 positive 4 times. Okay, if you struggle with this part, distribute it and see if you get the original. Negative 5 times 3 is negative 15. Negative 5 times 4 is negative 20. So that gets back to our original. All right, now you see that these two match, right? So make one of them your factor. So we got 3x plus 4. Your other factor is going to be x and negative 5. So put those on the other side. So we got x and then negative 5. So those are my two factors. So we factored it. And let me just rewrite this better. That's a minus 5. All right, so that's how we factor using the AC method. All right, so that was number 9. On number 10, we want to do x squared plus 11x plus 63. Okay, so let's do that over here. All right, this is not an AC method, right? So this one you're just doing the regular way, like this, a table. So 63 goes on top, and 11 goes on the bottom. And two numbers that multiply to 63 but add up to 11. All right, oops, this should not say 11. I'm sorry, that's a 16, not an 11. So let's change those two numbers. I went back to the problem and it said a 16, not 11. All right, so for 63, two numbers that multiply to 63 but add up to 16. In that case, it would be 9 and 7. 9 times 7 is 63. 9 plus 7 is 16. So now we can go straight to our double parentheses, x in each side. Notice that this is not AC method because a is 1 here, okay? So now we got x plus 9 and x plus 7. Done. That's it. That's all they were asking for. All right, number 11. Number 11 is factor 3x squared minus 3x minus 18. So 3x squared minus 3x minus 18. All right, so notice that the a is 3. So you would be tempted to use AC method, right? However, there's an easy way to do this. You can pull out the 3 because 3 goes into 3 and 3 goes into 18. So I would suggest pulling out the 3 before factoring. So like factor out the 3 before you actually do the normal factoring stuff. So let's pull out the 3. So if you did that, right, we would get 3 times parentheses. Now 3 goes into 3 once, so we got 1x squared. 3 goes into 3 once, but it's a negative, so it becomes negative 1x. 3 goes into 18 is 6 times, but it's a negative, so it's negative 6. All right, so that's what we get when we pull out the 3. Now, we no longer have to do AC method because the a here is 1. So we no longer have to do AC. So we can do the regular method. And a is now, or the top term is negative 6. The bottom term is an invisible negative 1 here. So two numbers that multiply to negative 6 but add up to negative 1. That would be negative 3 and 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So that works. So go straight to the parentheses form. So we got 3. Don't forget that 3. And then we got a double parentheses. So we got x minus 3, x plus 2, and done. All right, that takes care of number 11. All right. So now we want to solve quadratic equations using factoring. So let's do number 12. Solve using the zero product property. So we got 6 times 5 minus x times x plus 4. 6 times 5 minus x times x plus 4. And that is equal to 0. Okay, so we know that this is already factored, right? It's already factored for us, so we don't have to do any factoring. All we have to do is, since it's factored using the zero product property, ZPP, we know that each of these has to equal 0. So we can make this equal to 0. So 5 minus x equals 0. And then we have x plus 4 equals 0. Once you see something that's factored like this, right, with the parentheses and everything, and it's equal to 0, then you can set each individually to 0. So what makes this 0? Well, x has to equal 5. 5 minus 5 is 0. Done for that one. That's it. What makes this 0? Well, x has to be negative 4. Negative 4 plus 4 is equal to 0. So those are my two answers. That is all that they want there. Okay, so in this case, we did not have to factor because it's already factored for us. However, that won't always be the case. Sometimes we'll have to factor it. In fact, most of the time we'll have to factor it. So in this case, for number 13, we have p squared minus 3p minus 54, and they want us to solve that. And that is equal to 0. So when you see a quadratic, this is a quadratic equation. So notice that if you see a quadratic, make sure that it's equal to 0 on one side before you solve it. If it's not equal to 0, you need to make it 0, okay? So since it's equal to 0, we can go ahead and factor this guy. So a is equal to 1 here, so we don't have to do AC method. So go straight to the x table. Negative 54 goes on top, negative 3 on the bottom. So two numbers that multiply to negative 54 but add up to negative 3. Let's see, 9 times 6 is 54. And I know that if I subtract those, I can get a 3. I need the 9 to be negative though. So if I do negative 9 plus 6, that's going to give me negative 3. So those are my two numbers. All right, so now I can do the parentheses form, go straight to the parentheses form. Let me give myself a little bit more room here. So we got here, here, double parentheses equals 0. So the variable here is p, not x, right? So I'm just going to use p instead. And we got our two numbers, minus 9 and positive 6, so plus 6. All right, so we factor this. Now we're going to use the ZPP here, right? Zero product property. So what makes this equal to 0? Well, p has to be 9. 9 minus 9 is 0. What makes this equal to 0? Well, p has to be negative 6. Negative 6 plus 6 is 0. So those are my two answers. All right, pretty straightforward. Now let's look at number 14. X squared equals 5x plus 14. Okay, so now we know this is a quadratic equation because of the x squared. However, it's not equal to 0. We need one side to be 0. So we need 0 on one side to do this. Why do we need 0 on one side? Because we're going to take advantage of the zero product property. You can only use the ZPP when one side is equal to 0. So that's what we need to do. So I'm going to move the 5x over and I'm going to move the 14 over. So in order to move those over, I need to get rid of them. So this is a positive 5x, so I'm going to do minus 5x on both sides. And then this is a positive 14, I'm going to subtract 14 on both sides, okay? So now these cancel, so now you officially have 0 on that side. Now for these guys, just write them in a row. X squared minus 5x minus 14. There you go. Notice it's a quadratic that's in standard form, and it's equal to 0, which is what we want. Okay, now we can go ahead and factor this. A is 1, right? So we do not have to use AC method. So go to your table. Negative 14 goes on top. Negative 5 on the bottom. So two numbers that multiply to negative 14, but add up to negative 5. That would be 7 and 2. Negative 7 has to be negative because negative 7 plus 2 is negative 5. So now we can do the double parentheses equal to 0. X, we're using x for the variable, and we're going to use our two numbers, negative 7, positive 2. So we got negative 7, positive 2. All right, next use the ZPP. So we're going to set this equal to 0, so x has to be 7. What makes that 0? Well, x has to be negative 2. Negative 2 plus 2 is 0. All right, so that's number 14. Number 15, 4x squared equals 15x plus 25. All right, so number 15. Let's double check that real quick. Yep, okay. Alrighty, so now this is a quadratic equation because of the x squared. and we need to set, this is not 0, we need that side to be 0. So I'm going to move the 15x over, I'm going to move the 25 over. So this is a positive 15x, I'm going to subtract it on both sides. It's a positive 25, so I'm going to subtract that on both sides. So these cancel out. So write it in order, right? We want x squared going first. So we got 4x squared goes first, and then the x term goes second, minus 15x. And then the constant term, negative 25, goes last, equal to 0. All right, that's a negative. So now we have one side equal to 0, so check for that. Now, this is a AC method because a is 4, right? So we need to do the AC method. So let's do it over here. AC. So we got A is 4, C is negative 25. So we got negative 25. So 4 times negative 25 is negative 100. So we're going to do, so when we set up the x table, we got negative 100 on top, and we got negative 15 on the bottom. So two numbers that multiply to negative 100, but add up to negative 15. In that case, let's see, that will probably be, if we do 2 and, so we know that 2 times 50 is 100, but that doesn't work to make 15. We know that 4 times 25 is 100, right? But that doesn't give you negative 15. We know that 5 times 20 is 100, and that could give us 15. So 5 and 20 could work. And if we make 20 negative, then negative 20 plus 5 is negative 15. So there you go. So those are my two guys. So notice I did a trial and error. I just kept going until I found one that worked. So we got 5 and negative 20. Next, you're going to split that middle term into those two terms, positive 5x, negative 20x. So yeah, positive 5x, negative 20x. Those two numbers that we just found in the puzzle. Bring down everything else, minus 25 equals 0. Bring down the 4x squared, so 4x squared. All right. So now we can put parentheses around our two pairs, put a little plus sign here, and then put a parentheses around those guys. All right, so now we can pull out an x here, because there's only an x that they have in common, right? So we can pull out an x. So if I pull out an x, then this guy only has one more x left over. If I pull out an x from 5x, then I only have no x's left over, so just 5. I can pull out a negative from this guy, because we got two negatives. So I'm going to pull out a negative, and I can also pull out a 5 here. 5 goes into 20, and 5 goes into 25. So we can pull out a 5. So now, negative 5 goes into negative 20 4 times, with an x left over. Negative 5 goes to negative 25, positive 5 times, equals 0. These match. These always have to match when you do this. So now make one of those your factor. So we got 4x plus 5, and then we got here x minus 5, so bring those over. So x minus 5. All right, so now we got our, we factored it, right? And this is equal to 0. So now we're going to use the ZPP. So we need this to be 0, and we need this to be 0. Well, this one's easy. This one's x has to be 5, because 5 minus 5 is 0. So that one's done. This one takes a little bit more work, so we got to write it out. 4x plus 5 has to equal 0. So we got to solve that. Subtract 5 on both sides. We have 4x equals negative 5. Then we divide 4 on both sides. So x is equal to negative 5 over 4. So those are my two answers, negative 5 over 4 and x equals 5. All right, so that's number 15. All right, let's go to, we're couple problems away from being finished. So use the graph of the function to write the equation in factored form. So we need to basically use this graph to write it in factored form. Okay, so we can probably do it here. So for factored form, remember that an equation in factored form looks like, remember factored form is f of x equals a times x minus p times x minus q. So if we want that to be in factored form, well, remember that p and q are x-intercepts, right? So all we got to do is find our x-intercepts on here. Well, we do know our x-intercepts, right? So here our x-intercept is -1. See that? -1 right there? And we got our x-intercept here at -6. So we got our x-intercept. So we have our p and our q. So this right here, the -1, is our p, and in this case, the -6 is our q. So p is -1, q is -6. Let's plug that in. So we get a x minus p is -6 times x, or p is -1, I'm sorry, -1. And then q, so we got x minus q is -6. And by the way, it doesn't matter which one you make p, which doesn't matter which one you make q. You could just as easily make p -6 and q -1. So it doesn't really matter the order that you make p and q. As long as you got both of them, you should be good. Now we got double negatives here, so double negatives turns it into a positive. Okay, so we got f of x equals a x plus 1 x plus 6. Okay, so now we got it in factored form. However, we need to find a. So to find a, we're going to be using our y-intercept here. Okay, so in this case, we got x is equal to 6, or 0, sorry. And here, y is equal to 6, right? So y is equal to 6, x is equal to 0. So we're going to plug those in to here. So we're going to plug in 6 into f of x, and we're going to plug in 0 into x here and here. So if we do that, f of x now becomes 6. So we got 6 equals a. X is now 0 plus 1. Then 0 again plus 6. Now this is just 1, and this is just 6. So we got, let me just bring this down over here too, because I need more room. So 6 is equal to a times 1. 0 plus 1 is 1. And then 0 plus 6 is 6. So 6 times 1 is just 6, right? So we got 6 equals a times 6. So what does a have to be here? Well, a has to be 1. Divide by 6 on both sides, and you get a is equal to 1. All right, so then you're going to plug that in here and get your final answer. So the answer to number 16, and we'll write it, since we're running out of room here, let's write it over here. So the answer to number 16 is f of x equals a, which is 1, x plus 1, x plus 6. And there's our guy. All right, all there is to it. All right, number 17. So final problem. Write an equation for a parabola with x-intercepts of -3, 0 and 2, 0, which passes through the point 1, -12. This problem is kind of like number 16, except you don't have a graph. You're just given the numbers directly. So we know p is -3. And we know q is equal to 2. Now this we're going to use later, right? So we know we got f of x equals a x minus p x minus q. So we got a, p is -3, so x minus -3, and then q is 2, x minus 2. Two negatives make a positive, so we got a times x plus 3 times x minus 2. All right, how do we find a? We're going to use this point. So in this case, this is x, so x is equal to 1, and this is y, okay? So y is the same thing as f of x, right? So we're going to plug this into f of x. So f of x is -12. We got a times x is going to be 1, so 1 plus 3, and then 1 minus 2. We're almost there. All we got to do is find a, just like we did in the previous problem. So we got negative 12 equals a times 4. So 1 plus 3 is 4. And then 1 minus 2 is negative 1. So 4 times negative 1 is negative 4. So we got negative 12 equals a times negative 4. So we got to divide by negative 4 on both sides. So a is equal to 3. So now we know a. We can plug it into the final form, the factored form. So our final answer is f of x equals a, which is 3, x minus p, so plus 3, x minus q. And there's our final factored form. All right, guys, I hope you found this useful, and happy studying. So I would say go through these problems again, make sure that you can get them by yourself, and then check your answers against the answer key that you now have. All right. The problems are going to be just like this, where I'm going to give you problems that involve factoring, all these types of problems. Of course, make sure that you study enough, that you have enough time to be able to do these problems. And again, you can use your notes on the exam, but just make sure that you have a good set of notes so that you can be prepared for the exam. All right, best of luck, guys.